Hello everyone, this is Mrs. Logus and I will be taking you through Unit 3, which is the start of trigonometry. This first video is about the review of right triangle trig that some of you may remember from your time in geometry. And so it is my job to remind you of the important aspects. For instance, 3 of the important trig functions that you have learned in the past are sine, which is abbreviated with sin, cosine, that's abbreviated with cos, and tangent, which is abbreviated with tan. Now, in order to do right triangle trig specifically, we would need in our triangle to, for sure, see a right angle. And everything in trigonometry depends on an angle. And a lot of these videos that you're going to be seeing throughout this unit, everything relates to the angle. Especially if you take a look at these 3 mini equations here. Notice that we have sine of an angle equals a ratio, cosine of an angle equals a ratio, and tangent of an angle equals a ratio, which means that all 3 of these depend on the location of an angle. So when you're doing trig, it is important to label what angle you're talking about. And if you were talking about the specific symbol that's called theta, theta is a very typical type of way to name an angle. The side across from the theta, as a reminder, is called the opposite. The longest side of the right triangle across from the right angle is called the hypotenuse. And the side next to the theta is called the adjacent side, which is where opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent come from. So remember, it's all about the location of the angle when you're doing right triangle trig. Do you remember a memory trick for knowing sine, cosine, and tangent? What I'd like you to think about for a minute is if you remember a lovely trick from geometry. See if you can remember. If you're thinking SOHCAHTOA, I completely agree with you. And from years of teaching that trigonometry, I've noticed a way that students really like to help memorize is if you write a capital S and then as a ratio, SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And the 3 little equations that were on the earliest slide, like sine of theta or sine of your angle, is the same as opposite over hypotenuse. Now remember, I said everything is about your angle. That is because this is a trig function, so theta is what you're plugging in. So this is your input value, and this ratio is your output value. So the input or the domain of a trig function is an angle. The output or the range of a trig function is a ratio. And most of the time you will see a ratio written as a fraction, like 3/4 or 1/2 or something along those lines. Now, as kind of a silly memory trick for that, something I tend to say is when you look at sine of an angle, it's very common to mispronounce that as sin when you first learn trig. So what I like to write down is this silly little phrase, sine without an angle is sin. Now, is that really a sin? Of course not. It's just a nice little memory trick to remember that sine without an angle means nothing. So if I go back to the previous slide for a minute, here, sine without this angle means nothing. Cosine without that angle means nothing, and tangent without that angle also means nothing, because then you would not know where you're looking from in your right triangle. So let's get to practicing some of this trig again to get it back in our heads. Notice that all 3 of these trig functions depend on the angle called alpha, so I'm going to write this as a reference, make sure my eye goes there, which means if I looked at my triangle, 5 here would be the opposite side, 12 would be the adjacent side, but it looks like we're missing our hypotenuse. So we could either rely on Pythagorean triples if you still have memorized that this is a 5, 12, 13 triple. That works. If you don't, remember you could use the Pythagorean theorem. 5 squared plus 12 squared equals x squared. 25 plus 144 equals x squared. X squared would equal 169. So if you took the square root, you would get that the hypotenuse is 13. And now that we know that this length is 13, we can find all of our trig ratios. Sine of any angle is the ratio opposite over hypotenuse. So if we're using this angle as a base, opposite would be 5 and the hypotenuse would be 13. So this ratio would be our output value. The cosine of alpha, based on the same place, would be adjacent over hypotenuse, which is 12 over 13. And the tangent of alpha is opposite over adjacent, which would be 5 over 12. Now, something else that's good to point out at this point is, remember, it's all about perspective. So let's say that I called this angle down here beta. Let's just say that I wanted you to find the sine of beta. Remember, now your perspective changes. So if this is where you're looking, the 12 would now be your opposite, the 5 would now be your adjacent, and the 13 would still be your hypotenuse. So if you were going to find the sine of beta, you'd look from here, and sine is still opposite over hypotenuse, which in this case, from this angle, would be 12 over 13. So I just did that so you keep that little idea in mind. The next examples ask you to solve for the following unknown, and these have to do with sine, cosine, and tangent as well, especially since I see a little right triangle. And what's nice about trig is it helps you find unknown sides and angles. So what I would do is, in this first triangle, I would mark 15 degrees as a basis because that's the angle that you know. We usually don't use the right angle in trig. That's just there to help you know that you have a right triangle so you can use trig in the first place. If you look at the 25, its relation to the degree measure is opposite, and the other only labeled side is D, which is the hypotenuse. So if I write SOHCAHTOA up here, I'm thinking, because I have opposite and hypotenuse, that I'm going to be using the sine function. Now remember, sine without an angle is sin. So the 15 has to be attached onto your sine function. So sine of 15 is the same as opposite over hypotenuse. Or in this case, the sine of 15 degrees equals opposite 25 over hypotenuse D. I would say the easiest way to solve this was, if you thought of sine of 15, if you wanted to write that as a fraction, it's really sine of 15 over 1. And if you have two equal fractions, you can cross multiply. So you could say D times the sine of 15 degrees equals 1 times 25, which would be D times the sine of 15 equals 25. If you want to get D alone, you have to completely get rid of sine of 15, because remember, they are attached. So you would divide both sides by the sine of 15. And this would be a good point to remind those of you that have a calculator with you that towards the top of your calculator, you have a mode button. Please make sure that your calculator is in degrees, because we're measuring things in degrees currently. And also, I want to remind you that you have the sine, cosine, and tangent buttons on your calculator, I think above the 7, 8, and 9. So what you would do to find this decimal answer is take 25 divided by, when you press sine, you should see sine of parenthesis. Please plug the 15 in there. And if you did that correctly in your calculator, you should get the answer of that D equals 96.59 units. If we were to take a look at the second example here, this time our unknown is an angle, but that shouldn't stop us. We can still set up a trig function. Based on this angle, it looks like 20 is my hypotenuse because it's across from the 90, and it looks like 12 is not opposite, so it must be the adjacent side. So if I had to choose which trig function I was talking about, based on this angle, I have adjacent and hypotenuse, so I'm thinking about using cosine. Cosine of my angle, which is unknown, is the same as adjacent over hypotenuse. Cosine of my unknown angle is adjacent 12 over hypotenuse 20. So now our goal is to get the C alone, or the angle alone. And this is a good time to point out that this is technically called inverse trig, because in this example we plugged in an angle and got out a ratio, but in this example we are going to plug in a ratio and have to get out the output value of our angle. So unfortunately here, we're not allowed to divide by cosine, because cosine without that angle means nothing. However, we could use the inverse cosine on both sides. So let me recopy the problem so I can show you what I mean. If you take the inverse cosine on both sides, which is symbolized as cosine -1, the cosine inverse and cosine are inverses, so they cross out. So you have the angle C alone is equivalent to the inverse cosine of 12/20. Now in your calculator, to get inverse cosine to pop up, you would press second, and then you would press cosine. And once you have the inverse cosine coming up, you would type in 12 divided by 20 into your parentheses. And if you did that correctly, you would get that the unknown angle you're looking for is 53.13 degrees. Now it's time for good top-notch word problems. From the top of a tower 127 feet high, a ranger sees a small fire on the ground. So because this is the right triangle trig chapter, I'm going to draw a little right triangle and mark what I think is going on in the situation. So we have a tower. It's 127 feet high. A ranger sees a small fire on the ground. So there's probably a person on the top of this building. We'll talk about the angle of depression in a minute, but our goal is to find how far the fire is from the base of the tower. And base means bottom of the tower. So if I want to go from the fire to the base, this is the value I'm going to be looking for. Now let's talk about this angle of depression business. If you picture yourself on top of a building, your eyesight is usually looking horizontally. And then if you get distracted and look down at a fire, your eyesight is going to go down like this. So this angle right here is called the angle of depression. And the interesting part is that the angle of depression ends up being congruent to this angle. Some of you might remember from geometry that these two lines are parallel, so these are alternate interior angles, and so they are congruent. This angle also has a special name, the angle of elevation. So if you're looking up from the ground. So that means if this angle is 17 degrees, this angle is 17 degrees as well. So if I draw a little right triangle a little bit more neatly, I have my 17, my x, and my 127. I look at this and say, I wonder what my trig function will be. So what I'd like you to do is pause the video, see if you can decide if this is sine, cosine, or tangent, and when you come back, I will have it solved. You can compare your answers with mine. So the final answer I got here was 415.4 feet. The reason why is if I looked at this angle as a basis, the 17 degrees, I noticed I had opposite and adjacent, which made me think of tangent when I compared to the memory trick of SOHCAHTOA. So I used tangent. I then said the tangent of 17 equals opposite over adjacent. So the tangent of 17 was 127 over x. I cross multiplied. When I did that, I eventually had to divide by the tangent of 17. And when I did so, I got 415.4 feet. Last but not least, we have one more problem that I want you again to pause the video. I want you to see if you can draw this picture and see if you can set up your own trig function. And when you come back, I will have my work and I will talk it through. Hey guys, so to check in with you, I drew my little triangle here. I said that the truck 1 meter above the ground would be my vertical distance. The length of the ramp I knew had to be diagonal if you picture a ramp against a wall, so I called that 3. And I wanted to find the angle that the ramp makes with the ground, so I called this my unknown theta. Once I did that, I noticed according to this angle, I had opposite and hypotenuse, so I knew I needed sine. So I said sine of my angle equals opposite over hypotenuse. Sine of my angle equals 1 over 3. Because I needed to get the angle alone, I needed inverse trig. So I took the inverse sine of both sides. Over here, the inverses undid each other, and I was left with theta equals the inverse sine of 1 over 3. And when I plug this into my calculator, I got 19.47 degrees. All right, guys, so that was a review of right triangle trig. Lots in there, but good luck practicing in class tomorrow. Thank you.